You can use autograph to illustrate least squares regression lines and the product moment correlation coefficient. You can use autograph to illustrate questions like this. Bivariate data, it's number of hours practice and the student's exam score. So I'm going to switch to autograph and then I'm going to type this data in. I'm in autograph then. I'm going to open up my standard page which I've saved because I think it looks quite nice. And I'm going to go to data and enter XY data set. You can manually type it in. It's also possible to cut and paste. I'm going to paste it one variable at a time just to make sure that it all goes in there nicely. I can see we missed the top one out, so I'm going to just enter that one in again. I'm going to come back and get my Y values. So I've pasted my data in. I'm going to click OK. I can see straight away that we seem to have an outlier. So I'm going to click on that. I'm going to remove the outlier, which is now gone. And I'm going to then change my view so that we stretch it out so it all looks a bit better. Okay. I'm just going to zoom out, make sure I've got everything there, which I have. I'm happy with that. In fact, I'm going to leave that view where I've got there. So I can see that there appears to be a linear correlation here, except for this value up here. Now, I wonder what that equation is. What I'm going to do here, I'm going to select the whole set of data by drawing a box around it. I'm going to right click and I'm going to create a point which is the mean of the data, which is this point here. I'm going to edit the draw options so that that's really, really clear which one that is. I'm going to colour it bright red. So there's our mean point. I'm then going to create another fairly random point somewhere else. And what I'm going to do, I'm going to use these 2 points to draw a straight line through them. And now here's the clever bit. I'm going to select the set of data by drawing a box around it. And then I'm also going to select the line. And when I've done that, I am able to show the y on x or the x on y, the residuals. Okay. And the computer asked me how I want to do it. I'm going to draw squares for now. Okay. You may have spotted down on the bottom left-hand side here, it's adding up all of the residuals, the value of these squares, if you like, the areas of these squares. And it's also showed us the equation of the straight line as well. Now, what we're able to do here, from that point that we put in, I'm just going to click somewhere else, I'm able to move the line of best fit. And you can start asking students, what's happening to the squares? So as we move the line of best fit, what we're aiming to do here is to minimize or make least the value of those squares, the least squares regression line. We can see that that point up there is contributing quite a lot to this, but the task would be about making that value of all of the residuals as small as possible. I can see that as I am here, the sum of the R squares is 1,493, the bottom left there. As I move it, I've come down to 883, 1,008, so it looks like we're getting bigger again. Okay, so 901. So it's about kind of finding this smallest value of all of the squares, which for this example looks to be around there. And we could talk about the fact that this outlier is then contributing quite a lot to the value of those squares. You could, if you wanted to, from then, you could then click and change it from squares to lines and talk about that this is a y on x regression line. We're saying that the x values are good, we can depend on the x values, and that the error is in the y values. And so that's how come we've got vertical lines. How far out are the y values vertically from where we might suggest that they might be according to the line of best fit. We could, if we wanted to, we could delete those and repeat the process. So there I am selecting my data, selecting my line, and doing x on y residuals. This time we'd be talking about depending on the y values, and it's the x values that produce the error. And we could then quite easily see that there are in fact two different lines of best fit depending on whether we're doing x on y or y on x.